and that restriction is 1. Only one node is able to see the storage at a given time. So making it such a way that the owner node is the one that owns the cluster, and that's the node that's able to see the storage. And if you check the other node, you see all the services are offline because they cannot access this shared storage at the same time. So these are some of the limitations that you have. And there are all the differences that you could name that comes along with the difference between traditional failover clustering and always on. So we have what? A node monitor that monitors the health of other nodes through heartbeat network that I just showed you. And if one node was to fail, right, the health check will fail and a failover will happen, right? That's how a failover is triggered. Now, when that happens, let's say node 1 goes down, then node 2 knows what role node 1 was hosting, and then it triggers that because all that is registered, right? So this is really some of the ways that you can have, and for that reason, clients will be able to connect to node 2 because everything has failed over to node 2, right? So this will really make sure that you avoid any kind of interruption when you are doing when working with your mission critical databases, making sure that they are always up. So the only downtime that you will experience with the traditional failover cluster is only during the failover process, when it has to fail over, right? Okay, so when it comes to traditional failover cluster, we need to think about the hardware and the software that's required, right? So like I said, we need to think about a cluster hardware, right? In the cluster hardware, we will need to provide some level of redundancy everywhere. When it comes to the storage, there's built-in redundancy level of network, built-in redundancy at the level of even the cluster itself by having multiple nodes. You have built-in redundancy at the level of network interface, NIC cards, and then multiple network, and then the shared storage. So all this is just to make sure that in case one system was to fail, we still have another one that will drive the cluster. Now, and for the clustering, there are different types of storage that you can use out there. You have the fiber channel, internet. I really don't have a good understanding of all how this works, but today what we're going to be using is an iSCSI target. And an iSCSI target, what it really looks like is iSCSI stands for Internet Small Computer. Sorry, Jesus, it's falling behind. It's someone should get me. Jesus. All right. So it's Internet Small Computer something interface. I'm missing what that S stands for. And what it really does is this. It
stands for Internet Small Computer Systems Interface.
Thank you so much, Meg. Yes. So that's what iSCSI really stands for, right? And I'm going to explain a little bit with that with diagrams so you can really understand it. And that's what we're going to be building right now today, which actually helps you to mimic some kind of a shared storage at the level of this lab, so we can able to do our failover from one node to another, right? Now, so with networking, in this probably you're going to set up the networking, and we're going to also provide some level of redundancy at the level of network. And then here, what we're doing here, and I will not be able to create the public network because I don't have all the requirements that I need, but I'm able to create an internal network to help these computers communicate with one another, which means we're going to assign an IP address, we're going to build a domain controller, we're going to make sure that we make the IP address static, and we're able to test the communication between servers and make sure that they can talk to one another and fail over. So we're going to see that as far as networking is concerned. Now, a little bit about terminology, how this name has evolved with time. Back in the years, we used to call it Wolf Pack. I was actually surprised when I saw this name. And then by 1997, the name went to Microsoft Cluster Service, MSCS. And then from 2000 to 2013, we call it server clustering. And from 2018 and above, it's been turned to failover clustering. You've seen this WSFC very often when reading articles, which stands for Windows Server Failover Clustering. And this is what we're going to do. And it's the same, like in every high availability solution, it's built on top of a cluster, which means that the first requirement for you to build any high availability solution is that you need to have a cluster. In view of time, there's a couple of things that I've already done, and I'm going to explain to you what I've already done, just so that we can finish it with time, within the time that we have right now. So, and when you set up a cluster, you need to think about a quorum. That's part of a cluster to create a quorum, and a cluster membership model to avoid partition and split brain situation. Right. So in this situation here, where a quorum, what does a quorum really does in the system? It avoids the cluster from going offline. Right. So it's a voting disk system that really determines which node becomes it's online, and avoids that situation where the entire cluster goes offline. Now, there are different types of quorums that you will see out there. We have the node majority, the node and disk majority. You have node and file share majority, and disk only quorum. That you, for this exercise today, we are going to create a node and disk majority quorum for the exercise. And what this does is, for example, if you were to have three nodes like that, in a situation where you have an odd number, which is always like the recommended number when you're creating a cluster, is that every single node here will vote, right? Which means that the quorum for the cluster to stay active, you need to have the majority has to be the node majority, which means not 50%, because 50% is not a majority. We need at least a majority. So in this situation here, for the clusters to stay alive, we need to have at least two nodes active. But in reality, we can still run this cluster with just one single node. But you are going to see that as time evolved, Microsoft has actually made some changes. But in the old servers, what was happening is that you need to have at least the majority for this to stay active. Meaning that if this server was to crash for whatever reason, now you see one vote is down out of 3 votes. We still have 2 out of 3, which is still a majority. Now, if the second node was to go down, it's going down with the second vote, meaning we have 1 node out of 3. It is no longer the majority. The cluster loses its quorum, and the entire cluster will crash, even though this cluster could still keep running, the so-called one-man standing, right? So starting Windows Server 2012, what Microsoft has done is it has helped to bring in what is called dynamic quorum. And what dynamic quorum does is, in the dynamic quorum situation, the server is tricked to think in every single situation, the quorum dynamically changes its configuration. Now, if one vote was to go down, now this quorum changes this configuration and sees this as a 2-node cluster, even though one is down. So the 2-node cluster, and you have 2 of them up, because it's an even number. When it's an even number, one of the votes, the node, will be forced to give up its vote, which means one node will not vote. So in this case, the cluster sees what? Even though there were 3, 1 went down, dynamic quorum changes everything and sees this as a 2-node cluster, which is an even number. And in an even number situation, it will force one of these nodes not to vote. It will give out its vote, voluntarily give out its vote, meaning the cluster itself sees only 1 vote, right? It sees 1 vote. But when you set up what is called the quorum in this situation here, the quorum will then vote in that situation. But with dynamic quorum, it will change this to see this cluster like a 2-node cluster. Meaning even when this one goes down, right? Even when it goes down, this 1 node will still hold the entire cluster, and the cluster will not crash. And if this one was to go down, the entire cluster crashes, of course. So that's what dynamic quorum does. It changes the quorum configuration every single time a node goes down. It changes the quorum configuration, forcing one of the nodes to give out its vote, and the cluster does not see it as losing the majority, and it stays alive. So in as much as we create clusters on VMs, there's also host clustering. And what this host clustering does is it avoids a single point of failure when you are trying to create a consolidate, which means that if the host was to crash, right? One of the hosts was to crash, all the VMs that were sitting on that will be moved to another node, and right? And it will help to avoid a situation where the host that holds the VMs will crash and loses all that. So you have what is called V motion, where when VMs that are sitting on hosts, they are constantly moving from one host to another, right? The concept of the V motion. Right? So this actually avoids zero downtime during maintenance, and especially when you're doing live migration of VMs from one VM host to another. So that there's also clustering at the level of host, which is really beyond our own the context of this program today. But I just wanted to make sure you understand that it really exists. And of course, this guest clustering is what I've been talking about, which is actually helps to keep the application online. And even when one of the cluster crashes, there is a failover to the next node, and then we have the whole cluster still alive. All right. So very short explanation what this is all about. Now let me actually explain what I've done so far. Now, for us to be able to do this exercise, I'm assuming that you already understand how to create a virtual machine, right? And how to assign IP addresses to a virtual machine, and how to build a cluster, right? So I've already pre-created my virtual machine, and I did this using a VMware, and I think last year we did a presentation where we actually did this presentation from, it's hosted on MPIT YouTube channel. You can actually see how to create a cluster from scratch. So if you need that, you can watch the video, and once you have your cluster up, you can continue from this. So I'm assuming that we are DBAs, because everything I'm explaining most of the time is not done by DBAs. Probably you get a cluster already built, and all you need to do is go in there and configure the rest. Right? So that's the assumption I'm making here. So I have my domain controller that I've created, and on this domain controller, so let me pull it up here. I can connect to this domain controller. I have two nodes called node 1 and node 2. So we'll be creating a 2-node cluster, right? And on this 2-node cluster, we are going to create our iSCSI target and use that iSCSI target as our shared storage to configure traditional failover clustering. And if you want to watch more videos on iSCSI target, you are free to do so. But the only thing that I can explain to you right now is, if you look at the concept of the cloud technology, you can sit somewhere and access drives that are found in a distant server, a remote server. So an iSCSI target is just a distant server that provides you the storage that you need via a fast internet connection. Let's assume that I have my node here, node 1, and another node here. And I'm trying to create a failover cluster between these nodes. Now I can create a cluster here on these two nodes, node 1 and node 2. Now in the always on configuration, we would have each server here having its own storage, right? So where we do the installation. And then we have here a heartbeat that monitors these two servers. Now, but we are not doing always on, so we're doing traditional failover cluster, meaning that these two servers will need their own shared storage. So in that situation here, we need a shared storage where each one of these can access this server, and only one node is allowed to access the server at a time. So what happens now is we need to create a server. We need to have the storage from a remote server and present that storage to this cluster for this 2-node to see the storage as if it was local storage. And that's happened with the help of the iSCSI target server. We can do that, which means through fast internet connection, we will create what is called a target. And this target will use this server. Let's say we create a storage here called data. We'll have another one here called log, one here for backup, one here for TempDB. Now we can place this on our target, and this target will present this storage to this cluster, and this cluster will see this as a shared storage. And that's all the configuration that we're doing today. So meaning for redundancy and for disaster recovery, you are supposed to have this iSCSI storage sitting on a storage server. In most companies, there will be a storage server somewhere, that whose job is just to present the storage each time it's needed. Meaning when there's a decommission of the server, this storage is not taken away and can be used by a different application or different server. So that's all we want to do. And I'm going to just go into the demo and explain how to set up this iSCSI target. Any question before we go into demo? Any question, please?
Someone had a question. Shuri, I think it's on the chat says, is the failover automatic or manual?
The failover is automatic. So the failover is automatic. That's what I said. The only downtime that you have during this is when you are failing over. And traditional failover clustering will fail over within, the failover happens within 45 seconds. With always on configuration, the failover happens within 15 seconds. So there's a longer downtime when you have traditional failover cluster, but still 45 seconds is still better than having hours of downtime.
So that means you can have the option to set it for manual failover.
No, you can manually fail over. You can manually fail over, but there's no option that you set for you to do a manual failover only, right? There will be automatic failover. If a disaster was to happen, you automatically fail over.
So I think SQL Server failover cluster instance does not support automatic failover. That you're saying it does support it?
With failover cluster instance, remember what we're talking about here. Don't get confused between the failover cluster instance as the cluster. Remember, we are doing traditional failover, which is SQL cluster, which will sit on the cluster itself. The cluster itself does not fail over on its own. It is manual. But when you install the traditional failover cluster, SQL on it, then you are able to, the automatic failover will happen. That's what. So always remember, in traditional, in all this high availability solution, there is you always have the primary condition is that you need to have a window cluster set up.
Yeah. So
yes.
Doesn't it depend on if you have synchronous? It doesn't depend on that connection?
In traditional failover clustering, we don't have that option of synchronous or asynchronous commit mode. There is an always on availability group when you have synchronous and asynchronous commit mode.
Yeah, so, but, okay, so the first, to go back to your first clarification,
yes.
You said that right now we're talking about traditional failover cluster, right?
That's right. That's what we're trying to build, yes.
Okay, and you're saying it does support automatic failover?
Well, a cluster on its own, traditional failover cluster, yes, does support automatic failover.
Okay.
Not window clustering, right? Traditional failover cluster will support automatic failover. When a disaster happens, yes, it will automatically fail over within 45 seconds. And I'm going to demonstrate it here. You guys are going to see it.
Okay.
Right? All right. Any more questions? All right. Okay. So, yes.
No, sorry, you can go ahead. I was saying that I'll monitor the questions on the chat so that the questions don't be too long during your presentation.
Okay. All right.
Yeah.
Okay.
Quick question, Doctor.
Yes.
You said that the failover cluster will automatically fail over not window cluster. So I kind of get confused. It's not the same thing.
So, all right. So when you build a traditional failover cluster, right, you have the availability, and you have SQL Server installed on that. So the SQL Server that is installed, you're installing SQL Server as in a cluster installation, where you have a virtual network name, and it's that virtual network name that will automatically fail over in case there's a disaster. And it's through that virtual network name that every application will connect, right? We don't have what is called, it's acts more like a listener in the like in always on. So it's, if you just have a window cluster set up, right? There is nothing that will fail over. It's a cluster between two servers. But what is supposed to fail over are the cluster resources that are failing over from one node to another. It's not the window itself. Right? It's a window cluster, but you have cluster resources that are sitting on the window cluster. In case a disaster happens, those resources will fail from one node to another. All right, so let's actually see how it works.
I think people are getting mixed up. There is FCI, which is SQL Server Failover Cluster Instance. There is Windows Server Failover Cluster Instance. For FCI Failover Cluster Instance, it does not support automatic failover by availability group. So any availability replica that is hosted by an FCI can only be configured for manual failover. But you might need to configure a Windows Server Failover cluster to include a shared disk, that are really not available on all nodes. So, and these are things that we can also, if you have more doubt, or you can, research and get more clarification. But I think we should move on that. For any personal doubt, can basically do some research and, satisfy your doubt. I think we can move on, Dennis.
All right, thank you so much, Moses. Okay, so just to show you what I already have right now. So you can see that I have two nodes that are created. Node 1, let me bring up the screen so you can see that. We have node 1 and node 2. And I already have a cluster pre-created on these two nodes. And I can show you the cluster, or if I open node, let me go to node 1. I'll log on to node 1 and open failover clustering manager. You will see that I already have a cluster I just created. And this cluster is just a simple cluster with two nodes, has no quorum configured, and has literally nothing. I created a cluster called MPIT cluster, right? So this cluster here is a window cluster, Windows Server cluster, right? So, and it has no cluster resources installed on them. So if I expand here on the left and go to roles, you see that it has no roles. There are no roles. And you see, no roles. Now, if I expand down to the storage and I click on the disks, there are no disks found for this cluster. So it's just empty. So in order for us to use this, we could go ahead right now. If this was always on that we wanted to build, all we need to do right now is go ahead, install SQL Server as regular installation. And then from there, we're going to launch our always on availability group and configure them. But for traditional failover cluster, we need to have available storage, which is cluster storage, which will be available storage that the cluster can be used. We can use it to install SQL Server on that. That's what we're trying to do right now, creating an iSCSI target server that will use it for this installation. And for that, you need to do it on a server that is not part of this cluster, because if I was to do it on node 1 or node 2, and if any of those nodes was to go down, you're going down with the entire configuration and you're going to lose that. So we're going to create on a server that is not part of this cluster, the MPIT cluster that I created here, right? You see, there's no weakness here created. We're going to do all that right now. So let's go to DC, which is the domain controller right now, which happens to be the only node that I have right now, which is part of the domain that is not linked to this cluster. So how do we do that? So I'm going to go to my domain controller. And there's a feature that you have to install in order to do that. You need to go on add roles and features. And the feature that we need is a target, iSCSI target server. Next, next, next. And here, you have to scroll down to, I think I missed it before, on files and storage services. If you expand this, you see here, file and iSCSI services. So if I expand here, I'll see iSCSI target server. So I want to make this my DC a target server where I can create virtualize my storage, attach it to a target, and present it to my cluster as shared storage and use it for my installation. So next, and install. So everything that we've done so far is I'm starting up at the point where a cluster was already built, right? And everything is up, and I only need to add an iSCSI target server for my configuration. So once this is installed, we're going to go ahead. The next thing that you need to do is you are creating this iSCSI target server on the remote computer. You need to make sure you give access to the computer that will eventually have access to this target server. And that's what we call initiators, iSCSI target initiator. So we need to go on node 1 and node 2 and grant them permission to be able to see the storage that is created on this remote server for our installation. So let's just give it a moment. So I need to close everything running on my computer so I can have the best speed. Close and close. Don't save. Okay, it's installing. Close. Okay, it takes a moment to install that, but once it's done, we'll just move. So if you have any question, guys, why this is installing, you can ask right now.
So guys, is there anybody here that has not installed Failover Cluster before and you don't have an idea how that is done? Like Dennis said, we have a video already on MPIT Tech YouTube channel. You can check it out. But if you have, you should know where we are. So Dennis did not start from beginning. So if you're trying to follow this step, make sure that you would have done the initial installation of Failover Cluster. Then you get to the point of actually installing the iSCSI. So just want to make sure we know that. Is there anybody here who has not gone through that process? We can let us know while we're waiting for this. We can talk about it, and Dr. Dennis can answer any other additional question so we can use this time well, so we can see things still loading.
Yeah. And some of the things that most of us, the DBAs, might not have access to in a real environment is the access to Active Directory, access to DNS. Some of these things, it's good to have a lab environment at home where you can really play with it. If I was to go to my Active Directory and see what I have what is here, Active Directory users and computers. So if I open that, I'm able to see every single computer that is joined to the domain in the entire company. I can create service accounts, I can create groups, and I can create users and so on. So on this Active Directory users and computers, I'm just going to go ahead and create an account here, which we're going to use for our installation throughout this process. So let me just go in here and create a new account. So to do that, for those who have access, it's literally just click on new and select a user because that's what I'm creating. And I'm just going to call this one here admin, cluster admin account. And this login will also be cluster admin. So next,
can you tap the cluster well in so you don't get it mixed up in the future? Yeah.
Yes. Thank you for that catch. Cluster. So cluster admin, right? Okay. Next, and I just give it a password. Let me try password 1 and see our favorite password 1. I don't want to change the password at first login, and I don't want this password to ever expire. And this is what most service accounts are created like that, with passwords that never expire. All right, so I have that account, but this account has no privileges, right? Doing this while waiting for this to finish. Okay, succeeded. All right, so it's done. I'm going to go back. Let me just finish what I was doing here. So this account has been created with no permissions. So in order for you to give some high-level privileges, you can go on the properties of that account, and on the security is When it's not showing here, you need to go back here and activate these advanced features so you can see that. All right.
You can see it from views, right?
I wasn't seeing it. All right. Okay. So let's try again one more time. Security. There you go. Security. All right. So under security, I'm able to say I need to go on the member of actually and add this account under the member of administrators. It's all service account are members of the administrator, local administrator. So I add it. It's member of administrator. If I want this service account to do remote desktop connection to the servers, I can also go and add it as member of the remote desktop connection. Remote, big check. Should be able to see remote desktop. If I also want this, I mean, in rare cases, you will have this account being the domain admin. It's very, very rare. I really doubt you might not even have it as domain admin account, but I'm just adding it. It really doesn't matter. But so you see, so you can create accounts, you can give permissions to that account. This account right now, I'm going to use this as my service account for my future installation. Let's go back to where we were. So here we were installing the iSCSI target server. It's done. So if I close it now and I go back to this and expand this, you can see iSCSI. So right now, this is iSCSI virtual disk, which means I can virtualize storage, attach it to an iSCSI target, and present it to a server that is found in a very long distant location. And that server will see the storage as if it was local. That's just the concept behind all this. So to create that, let's just go ahead and create some targets. So create, click on that. Okay, so next. So I'm just going to call this one here data. Next. I'm just going to give it a space of 10 gigs and make it a dynamic expanding. Go back. So here, there is no target. We haven't created any target. So I'm going to create a target so that this server, this virtual disk can be attached to that target, and that target can be used to present it to the cluster that we have. So creating a new iSCSI target, and we'll just call it, let's just give it a name. I'm just going to create one application called MPIT. So we have an application for MPIT. So we're going to call that target also as MPIT target. Next. So now access servers. These are the servers that needs to see this storage. It's the storage is in the far distant location, but we need some servers to access it. So if I click on add, I'm able to give access to the servers that will eventually see this storage. So I click on add, and there are different ways you can find it. You can find it using the IP qualified domain name. You can find it with this DNS name with an IP or the MAC name. So I always like to go with the IP because I want to make sure I don't make any mistake. And I have to put the IP address of those two servers that we are creating this node 1 and node 2. And I have the IP addresses already. If you don't know the IP address, you can literally just go on command prompt and then just do ns lookup node 1, for example. If I enter, it will tell me the IP address of that node, right? It's 192.168.100.4. What about the other node? Node 2. What's the IP address? 192.168.100.5. So those are the IP addresses that I need for this. All right, so let's go. So here, I'm going to type the IP address. .4 and click OK. See, add it. Now we need to add the next one. Same IP address. 192.168.100.5. Add. So now we have those two IP. Say that you had a 3-node cluster. All you need to do is go ahead and add that 3rd node cluster here. Or let's say you started off with a 2-node cluster, and later on your management decided let's go to the 3rd node cluster. All you need to do is create that 3rd node, virtualize the node, add it to the cluster, and then come back to this target and add the IP address here, and you're good to go. All right, so that's all. Next, and create. So it's creating an iSCSI virtual disk, and it's going to create an iSCSI target. It's going to set the access for those servers, and it's going to assign the disks to the target that I just created. And then we're done. All right, so that's it. So now if I check here now, I see it's not connected. The target is there. The disk is there. It's not connected. But let's just go ahead and create the other disks because I need more. I need disks because Microsoft recommends what? Every single drive, single data log backup should be assigned to a different drive. So I need to have different multiple drives. So we can do that. Right click, new iSCSI virtual disk. And that's it. Next. We'll call this one here log this time around. Next. So because I already have a target, I'm not going to create any new target. I'm going to use the existing target to put that virtual disk on the target and create. At this time, we don't need to assign because the target is already created. Done. Let's do it again for backup. Next. Call this one here backup. Next. Make it 10 gigs also. And use the existing target and create. Okay, last one. Let's do it for 10 DB also. Next, call it 10 DB. Next, gigs. I mean, you will not need the same drives size for all this, but this is just an example. Okay, we have all our disks virtualized. They are all here as target connected to this target, but they are not available. The other drives, servers are not seeing it. So what we need to do right now is we need to go to node 1 and node 2 and initialize so we can see this storage that is created on a remote server. So to do that, let's log on to node 1. Node 1 is here. And we say on node 1, we need to go minimize this.
So sorry to ask. So
Yes.
so far, this iSCSI that we were creating, it was actually being created on DC?
Yes, on a
Okay.
remote server.
Okay.
Yes. Yeah. So in a real company, you will have that a virtual storage server whose job is just to provide the storage, and you will point it to the server, the cluster that you want to create. All right. So I'm on node 1. So I need to go on iSCSI initiator. So if I click on that, it will say it's not running. Of course, I need to start the initiator to be running. And once it's open, I need to make sure I'm able to access the storage that was created on a remote server. To do that, you need to first discover that storage. So you click on discovery, you scan the entire network to find the storage you're looking for. I can say discover and put the IP address of the server where the cluster sits on. All right, this is the IP address of the DC, 192.168.103. So if I click OK, it finds it, but it's not connected. So I need to click on that and connect to it. Now it's connected. So which means that node 1 is now seeing the storage that I created on DC. So all I need to do is go on volumes and devices and do auto configure. It sees all those virtual storage and I'm done. That's all I need to do. And I click OK. And I need to do that for all of them. Let me make sure I get this one up. Enter. It's becoming too small for me to see the bottom of this. Okay, there you go. There you go. Now we'll go to node 2 and do the same thing. So this is node 2. Tools.
I have a question.
Yes, please.
How did you decide the port number that I saw there?
Oh, the
so
port
three something.
Yes, 3200. That's the default port number for this iSCSI target communication. That's the default port.
Okay.
Yes, thank you. So on discovery, when you click on discover portal, you can see default port is 3260.
Can it be changed? And then if it is not a default, can it be any other thing?
I don't think it can change that. That's something to find out. But
Okay.
just like a default port number of a SQL, I don't think you can change it. I want to think that you cannot change this one.
No, not changing. Like, can you, okay, like you mentioned the SQL being 1433,
Yes.
but we can provide other port number if need be. So is it the same in this case? This is a default.
Yes, this is a default.
But
this is a default.
Is there any, I mean, is there at any point where there could be a need for you to have a different port number other than this default? It's just
it says here to change the default setting of the discovery of the target, click on advanced setting.
Oh, okay, so it is possible.
Yes, I think it's possible to do that.
Okay.
All right.
All right.
But there's something to find out though. I'm not 100% sure.
All right.
Yeah.
Good.
Okay.
Thank you.
So I discover it. Now, if I go on target, I see that it's there, but it's not connected. So I need to connect to that. I connect. So now node 2 is also connected to that storage. So on auto configure, it should be able to see that. There you go. Now we're done configuring. So at this moment here, we're expecting to see the storage on our cluster, but it's still not yet there, right? Now, if I go to node 1 and verify, what you see is that the cluster is not yet there. We are not seeing the storage. This is our node 1. If I go on File Explorer on this node 1, click on that.
Can you drag the node 1 VM up a little bit, because
you can see the bottom of it?
No, we can't. I mean, I can't.
Really?
Well, there is nothing Dennis can do on that. Like if your screen is not big, you'll not be able to see. If you have a big monitor, you should see.
Yes. You see that, Meg? That should be good now, right? All right. So
No,
you
it's
see,
fine.
even though we've created that storage and node 1 and node 2 are seeing it, it's still not here as local storage. We are not seeing it. So the next thing we need to do here is we need to go in there and initialize that storage so that these nodes can see it. And this initialization, you don't need to do it twice. You need to do it just one, because those two servers are accessing the same storage. So there's no reason to do it twice. It wouldn't even allow you to do it twice. So to initialize that, we need to go on disk management on any of the node 1 or node 2. We will see the storage there, but it's offline. And this is where DBAs come in. So everything I've done so far, most of the time, you will not be able to do this. This is when you will come in. You will join the team. The cluster would have already been created. The storage virtualized, presented to the server, and it's sitting there offline. All you need to do is log on, bring the storage online. So right click on this and bring it online. And you see it's not initialized. And right click, initialize it. Yes. Now it's initialized, but not allocated. So I need to create now a new simple volume for this. Next. I leave the drive later. I can change the drive later if I want to. Next. And I name it now as my data drive. Next. Finish. Right? It's now initialized. If you go back here now, you see that storage sitting there as a local storage. Look, it's local. It's not, it's still not really acting like a shared storage, because you can't move it across unless you add that available storage to the cluster as cluster shared storage. It will sit here as a local storage, right? So let's do the same for all the remaining 4. Now the next one here, I'll have to right click, bring it online, right click, initialize, yes. And then right click, create simple volume, next, and then call this one here log. Next, finish. Same thing for the rest of them. Move down. This one, right click, online. And oh, correct. It says already online. We try one more time. Online, okay. And initialize. I wish I could just do it once and everything. That's where PowerShell becomes very important. Next. I'm still the traditional way, guys. Back up. Let me go with TempDB for now. TempDB.
Quick question, Doctor.
Yes.
Are you making sure the name that you are giving here, like TempDB log, is it the same name, the name that you created the drive with?
It really doesn't matter at that moment because we're still going to go to the cluster and rename them so that they match exactly what we want.
Okay.
All right. Okay, so initialize and then create simple volume. Next, and then call this one here backup. All right, so we're good. Now it's been created, initialized. Now, if I check here, I will see the storage on this. Okay, so check. All right, so you see, these are the storage, but there's no way I can move this storage from node 1 to node 2 because it's not added as cluster shared storage, right? So at this moment, the only thing that I need to do is add this available storage as cluster shared storage, and we're good to go. So that's it. We open our cluster. If we expand this cluster, go on nodes, sorry, not on node, on storage, and go and click on our disks. We see here there's no storage, but if you click on add storage, it's going to check and see. There you go. We have available storage that we can use for the cluster. We add it now. It adds it as a cluster resources now. They come online, they're offline, and then they bring them online, and you can clearly see that these are available storage. And what happens here is it automatically chooses a node owner, and this node owner that will own this storage is always the host of the cluster, where the cluster is sitting. You can see current host server is node 1, and therefore the nodes, when they come online, the disks, they will also sit on the cluster that holds them. You can move them now. So if I go back now and check, you see that this cluster now is no longer as local storage, but it sits now as shared storage on node 1, which is the current host right now. Now I can move this storage from node 1 to node 2 because it's now available as a cluster resource. So if I go back to my cluster, I can say move available storage, and I can select best possible nodes or select a node that I want to. Let's say I have like multiple nodes here and I want to point this to a particular node, I can go to select node, but with best possible node, it will check which node is available and it will just move with it. So if I go select that option, you can see all of them are going offline and they're going to go back online, but this time around on node 2. So now you fail over. This is manual, right? You can move this storage from one node to another. Now, if I check again here on node 1, you see that the storage that was here is gone. It's shared storage, so it's no longer here. But if I was to go to node 2, if I move to node 2 and open File Explorer on node 2, File Explorer, then these things needs a lot of resources for it to work. All right, so let me click again or not. Node 2, okay, they open so many times this time around. And I click on this PC. Bingo, you're going to see the storage that was on node 1 has been moved to node 2. And we can go back to node 1 and do the same thing. All right, this is node 1. This is our cluster. Let me use the other method now to fail over so you can see. So I can move this available storage, say select node, and I want to move it to node 1. So move. You can see it's taking 1, 2, 3, 4, 5, 6, not that long. But when we add a cluster installation on this, it's going to be different. So you see now it's moved The owner right now is node 1. So now we have all the conditions available for us to do our installation. So the only thing remaining right now is go ahead and do a SQL Server installation as a cluster installation, not as a standalone installation. And for this, I'm going to load SQL Server 2019 on this server and run the installation for you to see. And remember, in SQL Server Traditional Failover Cluster, the first installation is the full installation, and then there's the node that is part of that cluster. What you're going to do there is you are just adding a node to an existing installation, right? It's like a whole bucket where SQL Server is installed only one, and anyone that needs access is just added to that bucket. We're installing SQL Server on the shared storage, and anyone that needs access to this is just added. That's why you need to go to the secondary and just add the node, right? For me to do that, I need to rename this server so I know exactly. Here it just says DIX 1, 2, 3 to 4. What does it really stand for? But if I click on this DIX here, and you see down here, it says backup. So I need to make sure I rename this to backup so I know exactly what I'm doing. So I go to properties, and I change this DIX 1 to backup. Do the same thing here. DIX 2 is data. DIX 3 is TempDB. You'll see the reason why I'm doing this. TempDB.
Oh, Dennis, you did not apply the previous one. It doesn't matter. You just click OK. You do not apply the one before this one.
It does. Yeah, it takes it. It takes it. But it's good to apply actually. This one is lock. Apply. Okay. All right. So we now have this. So let's go ahead now and load SQL Server in this machine and use that for installation. So I'm loading SQL Server Enterprise Edition 2019 on this server for installation. So I can go on my media, DVD. I'm going to eject what I have there now and then load a different drive. Insert a DIX. And here I do have my media location where I can load that media. So I have SQL Server 2019 Enterprise. There you go. I need to go with the core. It doesn't really matter anyway, but so 2019 is a standard. Yeah, this one. All right. So once it's loaded, if you check, this is node 1. If I go back here on the File Explorer, you see on my DVD, it already says here SQL Server Setup. So I don't need to copy the files to just load it directly, right? Just like in regular world environment where you have the VMware, you can easily load the media directly on the server, do the installation and eject it. Same thing works here with VMware, with Hyper-V, sorry. So I can double click on this now. And we'll launch the SQL Server installation. So while this is processing, one thing that we need to do is Traditional Failover is installed over a virtual network name. The virtual network name works the same like a listener in always-on configuration, meaning that incoming traffic will always be redirected to the primary. In this case here, incoming traffic will always be redirected to the active node. So what we need to do is just like in always on where we pre-create that cluster object called the listener, grant it permission and then disable it. We're going to do the same thing here for that cluster virtual network name. All right. So this is the wizard. Before I launch this wizard, let me just go to my Active Directory and create a list, an object, give it enough permission so that we can use it here for the installation. All right. So let's do that. So I'm going to go back to my Active Directory. On this my Active Directory, I'm going to create a computer object, right? New computer, and this computer object, we're just going to call the application that we're really installing here, MPIT app, MPIT app, right? Okay, so we have that application created as a computer object. Where is this? So go on computers. There you go. This MPIT app is here as a computer object. Remember, a cluster is also a virtual network name. It's a virtual network name account for cluster when you create a cluster. So this, we're going to use the same. So when we create this, we need to go on the properties of this, give it access to those on the security, make sure that we add those two servers. Note one, these are computers, check. Okay, note one. All right, we'll give it full access, full control. Apply. Note two. Apply, give it full control. All right. Now, what else? The cluster itself, the cluster, which is MPIT, was the cluster name. That's it. No, not the app, this cluster. And give it. So why am I giving permission to this? There's this called the DNS. And every DNS has what's called an A record, which means that when you create this cluster, this virtual network name needs to be inserted here, all right? And the DNS records need to be updated, especially in the situation with always on and always on with multi-subnet where you have multiple IP addresses, which means every single time you fail over from one subnet to another, the cluster has to come in here, delete this IP address on the DNS A record and insert the new IP address on the different subnet, right? So you are given that access full right over that cluster object so that the cluster can come on the DNS and make those changes for you when you bring it online. So when you do it, because you cannot just leave it like that, it will complain that the object is already there. All you need to do is after you granted permission, just go back and disable, sorry, you have to right click and then disable this object. Right now, the object is there, but it's disabled. So when we add it to the cluster during our installation, all the cluster will have to do is bring it online, and it works better like that. I'm not saying that it will not work even without doing this, but I found out that when you go through this approach, you have less issues dealing with this permission issue. So first create it, grant the permission, disable it, and during the configuration, it will just bring it online. So let's go back to note one. We're here during installation, so we launched our installation media, and you guys are all aware of this. We've done standalone installation for always on. We've installed SSIS package, SSIS tools. This time around, we've done upgrade. Now, this time around, we're going to do a new SQL Server Failover Cluster installation. All right, so we launched this tool. And once it launched, we're going to go ahead and do the installation. And one thing too that you need to understand is the decommissioning of traditional failover clustering. It's not like always on where you need to go to control panel on install features. You need to launch the same installation media in order to remove any installed instance in traditional failover clustering. So that's something that you need to be aware of.
Can you say that one more time?
Yes. If you, for example, now you've installed this instance and you need to uninstall it, the only thing you need to do is you can't just go on control panel like we do with traditional failover cluster, with always on, sorry, and remove that. You need to launch the same media to uninstall the feature. So which means you're going to come here. You're going to come here, and instead of on installation, we're going to go on maintenance and remove a note from SQL Server Failover Cluster. That's the only way you can install this.
Yeah, the process is different.
Yeah, so the process is slightly different. Okay, let's move on. So here, the licensing, we move next. And okay, accept the terms. Tells you what type of license you're dealing with. So one thing that I found out was this: if you create your cluster and you don't run the cluster validation check, this installation will force you to do it. It will not proceed. So I did it myself. I had to, during the creation of cluster, remember there's the step where you have to run the cluster validation check. That step is optional. But with this traditional failover cluster, you need to run that check. Otherwise, during this stage, when it's checking these files, it is going to complain that a cluster needs to be validated.
Okay, question. So
yes,
if you didn't validate a cluster and you get to this point, can you explain for record purposes what you will need to do, if any, to go back and revalidate the cluster, then come back here? And is there any way for you to jump the fence here without signing all the paperwork?
You have to sign up paperwork. You have to come back to the cluster and validate the cluster. Right? Just go to the cluster and click validate cluster, and you're good to go. It'll take some time and validate the cluster. Yeah. Wonder why this won't let me to skip this. Taking a little bit longer now. Make sure I have everything shut down.
Also, just to add to what Dennis was saying, when you're actually building the cluster and you validate the cluster, during that time you're building the cluster, once you validate the cluster, the validation report is what you will now use to continue to build the cluster that sets it up for you to where it has been set up like this.
Yep. Why are you taking this long? Should go faster than this. Come on. There you go. All right. So this is the time that it would have failed, right? It would have forced me at this point. It would have said cluster service verification warning. It's just giving me a warning right now. But if I did not run the validation, you will not move forward at this point, right? All right. Okay. Next. So this is the time now that we need to present the virtual network name that we pre-created in the Active Directory and disabled. Right. So if you've never installed SQL Server in the traditional failover clustering mode, guys, this is the steps, right? There's no other way to do that. So in this, I'm just going to select the database engine, going to do replication. I really don't need this. I really don't need this full text scan. I don't think I need this. Oh, looks like I have to select it though. Oh yeah, I can't go with that. All right, okay, so that's fine. Client to connectivity, I need it, and I also need backward compatibility. That's all I need. I really don't need all these other tools. Okay, next.
Yeah, okay. So while all this is going on, because this is getting to look like a familiar territory that everybody knows, I just want to take your mind back on why that is it. Oh, there's a particular cluster name that was disabled. I'm just taking your mind back a little. So my question is, why was that disabled? And if you don't disable it, what kind of problem are you setting yourself up for?
Yes, if you don't disable it, this is where that is coming in. All right. So if, okay, it's not actually here, but let me just get to that space. I'm going to call this application here, this an instant I'm installing MPIP, right? Just simple name, but I'm doing not a default, but a name instant called MP. Oh, sorry, SQL Server network name. This is where you actually have to come in. So that name that was disabled, it's a virtual network name, SQL Server network name. So those two servers, the failover is done via this network name. Right? So the reason why you have to disable it is because the cluster will have to bring that object online. And if it's trying to bring it online and it's already there, it's going to fail. And sometimes if you must not pre-create it. You could just leave it here, just like in always on when you are adding a listener, the cluster could create, you can add the listener during the creation of the always on and it will work. But sometimes it fails. I've noticed that it always fails when I do it in the whole process. So I always pre-create it, disable it, so it doesn't complain that the object is already there and I just need to add it here. So it was called MPIT app. And then we're going to create a name instance for this. And this name instance, I'm just going to call this one here MPIT class. Just so a little bit different.
Is there any reason why it can be default?
Well, I've never seen a traditional failover cluster with default instance. I mean, I don't know why. I've tried so many times with default and always fail. So
okay.
Room for revision. Check that out. I don't know why. I've tried, it always fails. So, but even in most environments I've been to, all of them always it's always a name instance.
Okay,
yeah,
so
I've also seen that traditional failover clustering doesn't work well with default instances. So it works most of the time with name instances, because even after installation, you see that it doesn't even go with the server name. Like when you install a name instance, you're going to have the server name / the instance name. But traditional failover doesn't go that way. It only goes with the instance name. So it works best with named instances.
Yeah. So the failover is going to be done via this virtual network name, all right? So and you know also that in traditional failover clustering, guys, availability is at the level of the entire instance, not like in always on where you can select single databases and fail over from one node to another. In traditional failover clustering, all the servers fail over. See, so this is the resource. This is going to be a cluster resource. And you see here, if we go to the next, it tells me the available storage I can use for this installation. And you can clearly see here, I can select which one I want. So far, I have backup, data, log, and tempdb. I need all of them because of best practice. So I select all of them. That's why I had to rename them earlier on. Otherwise, you would have just seen Dix 1, 2, 3, and 4 here. All right, next. So here, just like on a listener that has an IP address, this virtual network name needs to have an IP address, because how will Node 2 understand that there's already an installation? You need to add it to an existing, it connects via that IP address. So that's why we need to also assign an IP address to it. So, and this IP address, who registered this IP address in the DNS is the cluster. And that's why we had to give it permission so that it can register that IP address in the cluster. So I'm just going to click here and give it IP 192.168.100. And this range has to be on the same range with the cluster, right? If it's a multi-subnet cluster, you have 2 IP addresses, each in a given subnet. So here, I'm just going to go with 21. Next. All right. So this time around, we need a service account for the installation. And remember, we created that service account called a cluster admin. So we're going to use that account right now for our service account. Cluster admin was my service account that I created in the Active Directory. There you go. And the password, provide a password. Password 1. I can copy this here and put it here, and the password. Using the same for database engine and agent. And for some reason, you can't change this mode to automatic. It has to be manual. Okay. So the next thing that we need to configure right now are the storage. Where do we want to place our data, log, and tempdb drives? So, before then, here we need to allow mixed mode authentication and give a password 1 also as our account. So, I mean, this is just revision, right? You all know this. Okay, so I'm going to add the current user, and I'm also going to add any group that I want to have sysadmin on the server. For example, I want this cluster admin, cluster admin to also have sysadmin on that. So I'm just going to add it here. The DBA team group should just be added if you had created one before. And next is the data drives. So for my data, I'm just going to make sure I select, okay, I have here data. Remember, it's not a good thing to install something on the root directory, so I'm just going to create a folder here called MSSQL. And inside this folder, I'll create another subfolder called data. And I'll put it in there. For log, do the same. Log here. Yeah, create folder in the log for MSSQL and create subfolder called log. Put it there. And for my backup, do the same thing. MSSQL backup.
Yeah, all right, guys. Dennis, sorry to interrupt quickly. So that point that you just made casually is really important, where you don't have to put your data in the root directory. So it's good for people to pay attention to that. At least create at least one folder, but if you can do one folder and a subfolder, is even better.
Yes. And here I'm just going to create two subfolder here called data for TempDB and another one for log. Right? Okay, so TempDB here and the log for TempDB will go here. There you go. Done. Max.value for 2019. You have now the opportunity to configure your max.value. It was not the case with other previous versions. You can configure your max.value now. Why this is loading, I didn't configure my TempDB. You can see here, I'm not going to configure max.value as well as memory, but these two options now you have the option to configure it. But if you go back to TempDB, what you're going to see is that SQL Server automatically picked up one file, one TempDB file. Why? Because it's a server, a VM that I created, and this VM has just one call. So it automatically detects that it's going to be one call, but at least normally it will pick up the number of files based on the available calls that you have on the server. So the initial file size, I always like to give a bigger initial file size so that TempDB doesn't have to auto grow too much from the initial size. But companies have their policies, how they want to do this. That's have to follow company policy. All right, so that's all. Next, and install. As simple as that. So once this installation is done, we are going to go back to node 2, which is the secondary of this traditional failover cluster, and add a node to the cluster without doing a full installation, because we do want this installation is done on the same shared storage. So you can't add again on the same shared storage. You're only going to add a node to an existing SQL Server installation. So once this starts, I'm going to jump back and do other things while waiting for this to install. Can I have 10 more minutes?
Oh, yes, please. Well, I'll definitely want you to finish this and perform the demo for the failover.
Okay, all right, thank you. So, okay, so everything is good. And all I need to do is click on install, right? Okay, so while this is installing, let's do a couple of things. If we go back to this cluster, all right, to this cluster, what we're going to see is that this cluster does not have a weakness quorum, and we need to have one. If you check on the nodes itself, what you see is that one vote, the assigned vote for each node is 1, but the current vote is 0 and 1. Just like I explained, this is due to dynamic quorum, where one of the nodes forcefully gives up its vote and assigns and assumes a vote of 0. So long as this does not have a quorum which can provide the quorum node majority, this node will not vote. So if you configure a quorum here, it will push this node to vote. And once this node goes offline, the quorum will provide the available vote to make sure that this cluster does not crash. How do we do that? Let's go back to our domain controller. This is where we have all our iSCSI virtual disks. So we're going to create a virtual disk quorum. So what we're trying to create now is disk quorum. In always on, you have the option to create file share weakness and use it. Here you can create disk quorum, which will provide disk node majority to make sure the cluster doesn't go offline. So here I can right click. So this, it still says not connected, but the only thing you need to do is if you want it, it doesn't mean anything. If you just assign next, assign, it will just show you that everything is connected. See, it now says connected. Everything now is, I just need to refresh it maybe. But even though it says not connected, it is already connected. Huh? Otherwise, we will not be able to see it. So after a couple of refresh, it will come online. And you see that it will say connected. See, right down here, it says connected. So you can even ignore what is showing up there. All right, now it says connected. All right, so let's just go ahead and create one last drive, and we'll use it as our quorum. Next, I'll just give it 1 gig. It doesn't really matter, right? This you can even go with 500 megabytes, as small as you can go, and we're using the same target and create. Right? So it's created. Now I need to go back to node 1 and node 2 and initialize that. So while I'm doing this, the installation is going on. All right. It's taking a while to kickstart though. Okay, so I need to go here now and initialize. Repeat the same thing that we did earlier on. iSCSI. And we don't need to discover it because it's already there. So all we need to do is just go on the device and just click auto configure. See, it found the last one. So you have 1, 2, 3, 4, and then that's the last one we just added on. That's nice. I'm going to see in the bottom of this to click OK. Sometimes these clusters are, there you go. Okay. Now go to node 2 and do the same thing. So node 2, which is here. So this is our node 2. So on tools, iSCSI initiator, and it's already connected. We just need to go on device auto configure and it adds it there. Okay. Now we can now go back to node 1. I don't know why this node 1 keeps going back to the other screen. It's wanting me to push it across. And we can now go back to disk. I'm repeating the same thing, right? Going back to disk management. So this thing, guy, you have to be very patient with it. If you push it too much, it crashes and you have to start it again from scratch. So sometimes you have to be very careful the way you do it. All right, so I'm going to be gentle now. All right, so open it. And you can see this is the 500 megabyte that we created and it's online. It's not initialized, so right click, initialize. And then we can now create simple volume with it. Okay, new simple volume, next, 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 and just call it here quorum. Quorum. All right, next, finish. All right, so it's there. All we need to do right now is add it back to the cluster. I'm repeating the same thing I just did. Has this started? Oh yeah, that started. So open the cluster. And now we can now say add available storage. It checks to see the only available storage is this one that we just added. Click OK. And see, it's bringing it online. It's there. Okay, let's also do the, let's rename it. We click on it. And we can go here and say properties. Let's call this one here Quorum. 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 And apply, click OK. All right, it's there now. So but it's there as available storage. So all we need to do is go on our cluster itself and right click, go to more action, configure cluster quorum, right? Why is it getting this alert here? What is this? Operating system failure, disk management console. What is this? Let's not cause any issues here. Make sure I'm not going to cause any.
Maybe it requires an update. I don't know. I was reading the error message. Yeah.
Okay. But it's installing. So let's just hope that this guy, we don't break this, because it's very important that we have this installation succeeded. Okay, so let's go back to the cluster itself and try one more time. Okay, so we're configuring the cluster quorum wizard configuration. Next, what type of quorum we want to configure? We want to configure quorum weakness. That's what we need. And these are different types of quorum weakness. Disk weakness, file share, cloud weakness, or do not configure. I need a disk weakness, which will form disk node majority. This one forms file share node majority. This is the cloud. You can configure your weakness to sit somewhere in Microsoft Azure or AWS, and it will still work. Next. All right, it needs you to select which drive you want to use it for the quorum. I need this one. That's why it's important that you rename it so you can see which one you're selecting. Next. And next. That's all, guys, finish. And you can see here now on the cluster, it has a quorum. See, quorum is configured. Now, if we go back to the nodes, you see that the nodes are now voting. See, each one now has a vote of 1 because a quorum is there. And for that reason, this node sees no reason to give up its vote because there's a quorum that forms node, quorum, disk majority. All right. So let's verify how far this is gone. A little bit slow, on the slow side. Okay, so what else can we do here now? All right, now we've done everything. We're waiting for this to finish. And once it's done, we're going to go back and make sure that we add the second node, and we're done with the whole exercise. But why this is doing this? Let's just go back to Active Directory. Let's say you are a DBA and you're doing some good stuff, trying to make sure you follow best practices. I can go to my Active Directory. Let's create a group for DBAs that will later on access, because my job is to make sure that I follow best practices. So I'm just going to decide that nobody gets individual access to my servers. I'm going to create security groups. So I can come here and create security groups. Under users, I can create new and say, create a group, a security group. All right, so this security group, I'll call it DBA team. A DBA team group is a global security group that we're creating. We can give a description to that. after that, we can open the team and say, okay, who are going to be members of this team? At least all the DBAs that we have will be members. So let me just assume, let me not even just assume, I have some time. So let me create a group, a couple of users in this class, new user. I'm going to create Moses here as a user of that DBA team, and his name is going to be Moses. We just call OBM, Freight, right? So we have that user created. So let's give it a password 1. And since it's a user, we can allow that user to change their password each time, the first time they log in, right? And their password has to, okay, all right, that's fine. It's just a user, finish. Now let's create another user. Let's just say I want to create another user. Who are the members of this class today? Let's have another user for Bertie also. So and I'm going to go bait. All right, and okay. Okay, I'll allow you to change your password when you log in the first time. So just 2 users, I'm fine with that. So let's go back to the DBA team and say, okay, we're going to add members of the team. I'm just assuming that cluster admin was another member, just so that I have a couple of people. And add, and then I'll also add Bertie that was there as a user on that team. Oh, sorry, I spelled it wrong this time around. Okay, I'm going to say add also Moses. Now I'm going to allow him, who's going to manage this? I'll allow Moses to manage this team. And he's the one to maybe add or remove users in this team, right? Okay, so now it's a DBA team, and we also want to make sure that this team is a member of the administrator group, right? Because all DBAs should be. So administrator. Okay, and probably if your company likes you, they'll maybe make the DBAs part of domain admin. Most of the time they will not be, but if you get it, fine, that's fine, right? So we've created a security group, and we've added members. So each time a new DBA joins the company, all we need to do is make sure that DBA's name is created in the Active Directory and the name is added on the security group. And you can manage all your logins through this process. Every single time someone needs access, don't create individual access on the server. Just create a security group, maybe for analytical team, for reporting team, for whatever team, add the members under that team and only grant access to the team inside SQL Server. So that if the individual leaves the company, the moment the account is deleted in the Active Directory, you don't need to do any manual cleanup. So let's go back and verify where we are in terms of installation. Okay, it's a little bit slow. All right, questions?
I wanted to ask something. In an environment where you already have a cluster set up, but it didn't configure a quorum, is it advisable, I mean, with these steps so far, will it be advisable for someone to literally set up a quorum?
If it's not set up, yes, it will be. It should be advised. You should make sure that it has one.
Yeah, right? Because it's a 2-node cluster, and the side B, let's say, which is the node 2 in this case, is not pretty much active, but the node 1 is pretty much active, but they did not configure a quorum. So sometimes we always do have like a network bridge whereby the node 1 is, you know how the roles try to fail over, and when it tries to fail over, we always get the error message. But when we go back, it shows that the roles, not this whole cluster now, the role is trying to fail over to node B, but because of the fact that the node B is not active, it kind of caused a problem. So what we have to do in resolving that is to now try to fail back to the owner node, which is the node 1 in this case, and then we have to like fail it back, and then the rows comes back, and then everything is pretty much resolved.
Agree with you. All right. Okay, so while we're waiting for this, right, let me just go to node 2 and prepare the environment while we're waiting for this to finish. So the only thing you need to do, because node 1 is eventually going to be my active node, and then node 2 will be the passive node. So if you go to node 2, let's go ahead and load the media again, just like we did on node 1, and start the installation. So media, let me eject what I have here, and then insert the next media that I need to insert. So on media here, I need SQL Server 2019 core. Okay. All right. So once we do that, now here, so we have on this, you can see that SQL Server is already loaded in here. All right. And you can see that there are no storage here, right? Because node 2 is a passive. All that shared storage is sitting somewhere in node 1. There's nothing here. So let's just launch the installation. I have never tested if I could add a node if the primary installation is still running. So I'm just going to keep doing it until the point of validation, and I will stop there. All right. So we're almost done, guys. Just this, and then we'll test the failover between the nodes. So normally in the situation where you want to test an active configuration, right? All right, so okay, so on installation. So in this case here, when you launch the installation, this is the secondary of that cluster. You are no longer going to go on SQL Server Failover Cluster installation, where you are going to add a node to an existing cluster. So we select add a node.
While we're waiting on that, how does the active work?
So the active will work in the sense that right now all the storage is sitting on node 1. Remember, in traditional failover cluster, only one server can access the storage at a time. Meaning, if we want to make this an active configuration, what we need to do is that we need to have 2 instances installed. Let's say we have MPIT app and an MPIT dev app application that are supposed to run, and they are all very resource intensive. And we want to make use of the resources that we have on node 1 and node 2, right? We don't want to run all of them. So what we need to do is that we need to go back to the iSCSI target and create storage for MPIT dev app application, and then go through the entire process, initialize it, make it available, add it to the cluster, and then when we do the installation, we use the second storage that we created for the MPIT dev app and make sure that we fail over that second application to run on node 2. Node 2 will be the primary for that app, and this MPIT app node 1 will be the primary. So in this case, we have an active configuration because node 1 is running MPIT app, node 2 is running MPIT app dev application.
But both of them have this they have different storage.
Yes, they have different storage because you can't have both of them at the same time. You can only use the storage one since it's shared storage.
But in this situation, is it gonna be okay, sorry, what was gonna say something, but is it possible that it's just gonna be only 2 nodes to be active, or it could be more than 2 nodes, right?
It could be more than 2 nodes. I think always traditional failover cluster can support up to 64 nodes, if I'm not mistaken. Right? So you could have active, passive, or you can have active. Let's say you have 3 nodes, for example, and you install 3 instances. You can fail over, make sure each instance run on the node. In that case, you have active. Or you have active, and one is standing by, so it'll be active, passive configuration. Really depends on the way you set it up. All right. Okay. So while this is running, Let me quickly check on that primary to see if it's done. It's a really bit slow though. Expecting this to be done by now. I have 32 gigs. It's sometimes slow.
I'm suspecting the network.
Yeah, it's really bit slow. It's done by now. Yeah. Okay.
Doctor, while we're waiting, right, I have a concern here, which something I experienced at work. It's a little bit out of traditional failover clustering, but since we're dealing with clustering, I just thought about it. Let me bring it up.
Okay.
So it's an always on availability group. So today we had outage on a DR site. So by the time the outage happened, the primary was the DR server. So the server went offline, and then when it came back, the SQL services were stopped. So I expected the availability group to have gone back to the primary, which is the Houston server, but it did not. So I only got an email. People were reaching out to me. They could not access the application. So when I went in there, I realized that the primary I could not connect to the primary. So I had to RDP into the primary server and realize that the SQL services were stopped. So I was wondering why the SQL services were stopped. And even if they were stopped, why did it not initiate a failover? Because everything is configured automatic failover on both servers.
Where does the quorum sit? Where's the cluster quorum sit? Is it on any of those?
Okay, that is one thing I did not. I talked about the quorum, but I have not RDP into the server to see where the quorum sits. But I believe that quorum should have been on the Houston server, which was the secondary at the time.
So probably then, if that was the case, if it's sitting on one of the servers that is part of that cluster.
The quorum sorry, the file share quorum where it's created?
Yes.
No. I believe it was created. I don't know. I got the one that was already created, but I don't believe the quorum sits on one of the nodes. I don't know. Okay. Really, I cannot trace. I don't know. I don't think the quorum can be created on one of the nodes, though.
I mean, you can do it, which is not a bad practice, but it will still be there. But if that situation happens, you are losing both votes.
Both nodes.
Yes. Yeah. Yes.
So Foster, besides the part of the quorum, was your service on automatic?
Yes.
Okay.
My SQL Server services are set to automatic.
Okay, and this was always on, and
always on.
It was automatic failover as well, right?
Yeah, that's true, because when you started talking, my mind was if the services was auto. So if you say yes, then that kind of threw me off. Why
should come online?
Yeah, why didn't it come online? I mean, it could be really rich people.
Doctor, I want to ask something.
Yes, Meg.
So
yes.
In a situation,
Meg, hold on, please. Sorry to cut you. On Foster's concern, Foster, by just restarting your service, everything came back up, right?
Yes.
When you restarted it manually.
Yeah, services, the SQL services online by the availability group database. The secondary availability group was in the resolving state. And then the primary, now the databases were not in sync. So when I restarted, most of them came in sync, but the main application, which is the heaviest, about 3 terabytes, would not come online. I had to manually go suspend data movements, resume data movements, and refresh before it came online.
I mean, let's say, for example, not even in always on. I've had a situation where even my server goes offline or got rebooted for whatever reason, and when it came online, the SQL services were stopped.
Wow.
Right, and I had to manually start it, even though it says automatic startup mode. So I don't know. But
what you said, Doctor, I think I'm going to that tomorrow to see where that quorum is created. It might have been that the quorum sits on one of the nodes. The reason why the availability group did not fail over after the services.
Yeah, I think that is likely to be the reason. Like,
I will do that.
80% likely. Yeah.
Thank you for that. Though. It's an eye opener.
So we're almost done, guys. It's almost done. I did everything possible to make sure that we get this in 2 hours, but it looks like all the preparation work.
This is not your fault, Doc. I mean, we can all see the what do you call it? The installing being slow. This should have been fast for you, but I mean, all in all, it's interesting, and I want to believe I'm speaking for everyone. We want to see the final results, and these are things that are going to help us at work. And the off-scene, behind-the-scene talks coming up, trust me, is all very helpful. So please, guys, be patient as we're pushing. You know, extra time for this is important and valuable for you.
Yep.
Okay, Dennis, I have a question. I'm not sure if I will be able to. This question is about over 45 minutes late. So the thought of is a little outdated. You made a statement after the first installation, as in the SQL Server installation.
Yes.
If you want to install another node, that you don't have to, I don't know. Okay, is that, I'll go ahead.
Yeah, if after I was saying that after this installation, which is the first installation, since we're putting everything is installed on this file share, right? It's like a bucket. We're putting everything on the bucket. If the second installation, which is the adding the node to the cluster, you are not going to do a full installation anymore, because the share storage already has all the binary that it needs, and you don't need to do brand new installation. You just need to add the node to the cluster. That's, I think, except
on the passive node.
On the passive node, yes, the passive node. Yeah.
Gotcha.
Yeah, it's
so, Doctor, while we're waiting for this, I was going to ask you a question pertaining this, though.
Okay.
I mean, it's what we're doing right now, but in a different way. What if the two nodes happens to be on different subnets?
Oh, yes. If they happen to be on different subnet, so what we need to do is, remember when I added the IP address for the virtual cluster name, and that IP address was on the subnet that the cluster is sitting on. If they were on different subnet, you will have the option to select which subnet you want to add. So which means this virtual cluster name will have 2 IP addresses, 1 per subnet. And in this case, it's really, really important that you make sure that that virtual cluster name, that computer object, that the cluster has full control over the computer object, so that when you fail over from one subnet to another, it should go to the DNS record, delete the IP address that is there, and insert a new IP address on this next subnet. Otherwise, you're always going to have issues called IP conflict issues. And I have some good documentation online that Microsoft has written on that, when you have clusters created with multiple subnet. It's a well-known issue with Microsoft, yes.
But is it possible to use just one IP address? I mean, you're going to have the 2 IP addresses set up for the 2 subnets, but is it possible for you to turn one of the IP addresses off, and then it only sees 1 IP addresses from the subnet? I mean, have you?
It defeats the entire purpose of having a multi-subnet, right? Because the multi-subnet is for DR purposes. In case something happens on my primary data center, I can fail over to the next. Well, since this is done, so let's quickly go to the next one and quickly do that. All right. So you see the primary installation is finished. Let's go to the next and continue from there. So I stopped here. So let's move on and see. I hope you wouldn't ask me to go back again and change. Let's see. Looks like I have to really start the whole process now. Rerun. Okay, so the validation, everything looks well. Okay, the only warning is that cluster verification warning, which is fine. We already validated it, so it's not an error. Okay. All right. Next, hopefully it sees it this time around. There's no SQL Server Failover cluster available to join. What do you mean by
Yeah,
no?
doctor, normally you have to wait for the first installation to be completed,
Exactly.
completed before you can go to the secondary and
So
add a note.
you have to
Trying to win time.
Yes.
All right, let's try it again.
Too fast.
Let's try it again. All right. Okay. I thought that if I go all the way to the point where I'm waiting for this to come online, you should see it. But yeah.
Don't forget, it has to be completed and get registered or wherever you DNS or what then.
All right, let's do it again this time around. So
now we're on the passive node.
We're on the passive node. So in this passive node now, we are just doing add a node to a failover cluster. Right. All right. So wait.
So far we have the node 1 already completed.
Node 1 is completed. So now we're going to the passive node to add a node to a cluster. These things are only during conference presentation, they decide to slow down. What I'm doing it by myself is a little bit faster than this.
Zoom is a little bit slow these days.
Can you close any of your browser, like Microsoft Edge or Chrome, those guys? Okay, can you go to your task manager and see what is taking CPU up at this particular time and kill that temporarily?
Zoom.
Oh, there you go.
I told you, I said Zoom these days.
What is Skype doing here? Let me kill this one. What else? Nothing really. It's Zoom. Zoom is taking, my goodness. All right. But I still have a lot though. It shouldn't be slowing down.
It shouldn't be 60 something. Yeah.
All right. Oh, come on.
All right, guys, while we're waiting for... No, it's already loading. Yeah. So while we're waiting for this guy, somebody asked a question, how they can get this video. Usually what we do is that all our webinars presentation, we try to post them on YouTube. So if you go on MPIT Tech, just type on YouTube MPIT Tech, you'll get to our channel. Try to subscribe so that when we post this video, you'll be able to get it. But it's definitely going to be on YouTube the next 48 hours at most.
Yeah. And guys, really try to subscribe though. That subscription is very important. Most of us have not subscribed to that channel. It's important to subscribe.
Please,
even if you don't want to watch videos, just subscribe. It doesn't hurt. No.
Absolutely.
When you subscribe, turn on the post notifications. That way, when they upload every video, you get a notification.
Yep.
Thank you for mentioning that, Dr. Kerry. So, guys, I think that answers that person's question. So, if you go, make sure you subscribe. If you subscribe, as soon as we post this, we will title it just the same way that we advertise it. And whenever we are advertising any webinar, we are really trying to open it up for SQL's community, not just within our, friends, or at most maybe Kiawi Tech team. No, want to go beyond that. So when we share the flyers, please share it on your social media platform. Let other people join and then benefit from this. Because even if you have 20 people or 30 people or 60 people, it's the same effort that would take the presenter to talk to 1,000 people. If we can accommodate them, it's the same effort, the same energy that you use in talking to 5 people, or, so the more the better. So let's feel free to share it. And we try to do it every week and new topics. And right now we actually have like some exciting topics lined up for till the next, I think 4 weeks back to back. So let's look forward to it. It's always going to be the same Zoom information. So join, it's free. You don't have to know me. You don't have to know Dennis or any of us. Feel free to join and feel free to share it. Let people join.
Yeah. And see, guys, you can see that the server name right now, the server instance. So the failover right now is it picked up the server, the instance that we installed on the other server. Remember, this was the instance that we used, MPIT class. Now it automatically picked it up now, and it also picked up the virtual network name that we created called MPIT app, and all the features that were installed, it also picked it up. And here, we don't really need to, we click on the IP address. Let's, hold on, check. All right, so if we check on the IP, we don't even need to insert the IP. It already picked up the IP address that we inserted on node 1. And moment. And the only thing I need to add here is the password. It already picked up the service account also. Password 1. Let me make sure I got the password right. Password 1. And next. You can see here, everything is done, and all we need to click is install, and we're done. All right. Hopefully this one won't take long. All right. So Mickey J, if you don't mind, maybe you can put also the link here on the chat, so others can also click on that.
Yeah.
Sometimes we easily forget most of these things. We'll say we're going to do it, and then we hardly do it. Yeah.
Yeah, we can post the YouTube link right here so people can just go and subscribe.
Yes.
While we're waiting for this, guys, I believe by this weekend, we're planning to have an initial planning meeting for our conference. So I just want to give us a heads up. I think by this time next week, we should be announcing the date for the conference so we can start to plan. Hopefully this time around, we're not doing virtual, even though some people can connect virtually, but we really want to encourage people to, plan to fly to Miami, Florida for the conference, but we're going to announce the date very soon. So, but this weekend, we hope to have like a planning meeting where we're going to decide on, the date. So please keep your calendar open for the coming summer. I know some of you plan for your summer in advance. So we at least will give you a minimum of 3 months to plan. All right. So just wanted to mention that. And there we usually will, have a lot of hands-on training. And this year is going to be super packed. Besides the knowledge we share amongst ourselves, I'm trying to talk to, one of the industry SQL celebrity, quote unquote, to be able to honor us with its presence. So we're still doing the initial, discussion. So as soon as we get everything solidified, we'll announce the name, and then plus, some of our team, some of our people that usually will help, share knowledge and what we've learned over time, we'll share with people, and we'll have enough time all day, to really spend time learning. And of course, the fun part, you guys always remember that. It's always one of the best part of it, where we really, unwind and just have fun together. And another good thing about it, guys, is that I'm seeing it's still loading, so I can talk a little bit. Another good part about our conference is that you get to socialize, you connect with people. There are some of you here that I believe from our last conference, you contacted, people, you make contact with people. And then since then, you guys have been best of friends and working together. So there's something different when you only talk to people virtually. And when you meet those people one-on-one, you get this connection that you can explain. And when you call after the conference, you need help, any SQL related help or any technical assistance or support or ideas, the person is talking to you like, oh, this is my body, man. This is my girl. You know, I need to support her. I need to support him. So it goes way beyond just, you know, going to learn something new and bringing it to our companies where we work, or our future companies where we hope to work and add more values, you know, and be the rock star in those companies. So plan for it. We're going to announce the date as soon as we conclude a few things this coming weekend. We'll let you guys know, but I just wanted to mention it while we are waiting for this to load, that we should plan for it. We're definitely looking at this summer.
All right. So while this is almost completing, I can already take you to note 1 so you can see what is already going on there. This is note 1. So remember I said traditional failover clustering availability is at the server level, right? The server level, not at the database level. So right now a role has been created, and you can see that that role has the instance name, the instance that we install called MPIT class. And this instance is running on the primary, which is the active node, node 1. Now, if you scroll down now to the DIX this time around, what you're going to see is that the DIX, earlier on, we had this as available storage. Right now, it's no longer available. It's now has been assigned to that instance that we created. Remember, every single one of these drive here was assigned to backup, data, log, or TempDB. So it's no longer available. So you can't use this storage again for anything else. It's dedicated for this instance alone, and the node owner is node 1. If we were done with the other one, I will literally show you how to fail over. And to fail over with traditional failover clustering, what you need to do is you go on the roles and you right click on the roles that have been created, and you say, oh, sorry, click on it. Sometimes you can also use this option here. Go on move, right? Move these to select a node and select which node you want to move it to. I want to move it to node 2, and then click OK. It's going to move this role from node 1 to node 2 because this role has its storage. Remember, the storage is assigned to this. If you go back to DIX, you see that the storage is assigned to that role already. So when you move that role, you're also moving the storage with it, and it will fail over. Let's say, for example, node 1 was to go offline. This role will automatically fail over this role to the available node, and that will complete the entire process. So let's see, this is still very slow. Yeah. Expecting this to go fast. I thought adding a node was not going to take that long. But that's really how you do this, guys. Literally, that's as simple as that, right? Okay. So while this is doing this, so let me quickly also go on my, yeah. Well, I mean, at this point, do you guys actually need to see how to connect? I mean, it's, remember the failover in traditional failover clustering is not at the level of SSMS, like in always on, where you have to log in and fail over. The failover in traditional failover cluster is at the level of the cluster itself. You fail over here. That's where you do the failover. If I have to show how to connect, I will need to install SSMS on one of the nodes, which I don't know how long it's going to take, but let me just, yeah.
Oh, I thought you had it so you could connect and see how the instances they get created, because as we said, it's best to create it. It uses name instances, right? So when you connect, you're going to see that it has nothing to do with the server name. Yes. You only create the instance, you only connect using the instance name that you provided during the installation.
Yes. SSMS doesn't take long to install. It could even finish before that.
So from the way it is, I think everybody's really interested to see the endpoint. So
okay. Okay, so I'm going to move, copy SSMS to this node 1, launch the installation here. And for one thing I realized with these servers, it easily copies something to the desktop and goes faster than copying it anywhere else. So I have SSMS here. I'll just drag it and drop here. Paste. All right. All right. So where this is going, I think you can pause maybe the video just a little bit. So once we get it before, otherwise make it too long.
Okay, that I can do.
All right. Okay. All right.
All right.
So what we've done, we've successfully installed the SQL Server cluster installation on the primary, and we added a node on the secondary, and then we also install SSMS, so at least we can demonstrate how to connect to that instance that we installed, and it's requiring me to restart right now. So after the restart, we'll be able to connect, demonstrate how this works, and then we should be done with it. Yeah. So, all right. So at this moment here, I've just restarted node 1, which was my primary. I was okay. So if you go back now to the cluster and open on node 2, you will realize that it has failed over. This is something I should have actually looked at. Remember, our node 1 was our primary. So this is a disaster that we've just caused. Let's see if it actually failed over during this process. I didn't think about that when I was restarting it.
Which node did you restart? Node 1?
Restarted node 1, which was the primary at the time.
Oh, I see.
Yeah. So we're expecting, I mean, just from the digs, we're expecting to see the digs sitting here now.
But if your node 1 was a preferred node, once it comes online, it will fail back to it.
Yeah, I didn't configure anything like that. I just configured directly.
Traditional is manual.
But yes, but you can see even from the digs now are sitting on node 2. It just tells me that it did fail over. All right, so if I open the failover cluster manager, okay, so the cluster comes back online, and if we check the role, see that it's on node 2. Why is it saying pending? Actually, let me verify this. It's just a little bit slow. All right, so they're all online. It's just slow. All right, so I have to refresh this for it to show. It could take up to 45 seconds to fail over, right? So let's connect to this one and see how we can connect to this. Straight off, administration. Straight off. All right, guys.
Who wants to swallow us?
You know, it's a little bit longer than we thought, but all right. Okay, so let's launch node 1 and open SSMS. Make sure we, all right, see, it's now online. It just, remember the traditional failover closing can take up to 45 seconds to fail over. This was a little bit slow. Also, network could also influence the time it takes to fail over. But you see that the role came back online and it's on node 2, right? Node 2 now is our own node. And if you can even look at the cluster, you see that the quorum, right, the case, because we rebooted node 1. So this is, for those who are asking the question, if traditional failover cluster can automatically fail over, this should answer your question. All right, okay, so let's actually open SSMS now and see how we can connect SSMS. Okay. So one thing I found out when I checked the resource consumption is really running at 100% CPU. That's why it's slow. So I don't know how to add CPU with this. You see, it's running at 100% CPU. When you create this cluster, these VMs with this Hyper-V, there might be a way to add the number of cores, but I don't. The host doesn't have that enough. So it's but normal that it will just pick one. And it's really resource intensive. That's why it's slowing down, because we are maxing out and everything. Yeah. Close this one now. Yeah, goodness. All right, so let's check back on note. That's note 2. All right, so the rules online and the storage. It's all sitting on note 2 right now. All right. Okay. Why this one is coming online? If you were to do a failover, right? It's as simple as that. You click on the node, on the role, right? Click on the role, and go on action, move, and select the node that you want to move to. You have multiple nodes. They all show up here. You can click and failover. What you're seeing that is going offline. And what you're going to see also on the disks, all the disks is soon going to go offline. Once that one goes offline. Right now, it's still sitting on node 2, but once it goes offline and come back online, see, it's still pending. So failing over is a little bit slow. To fail over to node 1 now. Why this is happening? Let me go back to node 1 and see if SSMS is loaded. Jesus Christ. Load common SSMS. Damn it. Sorry. Why is it taking ever to load SSMS? All right, let me go back to node 1 and verify. Of node 2. Node 2. Failing over is really slow. See, the disks has already failed over, right? They're already now on node 1, and the role eventually will. But in corporate world, this is faster than this, though. So don't expect that this is the speed. This should take within 45 seconds. It should fail over. Let me refresh and see. All right, it's already on node 1, but it's still pending, coming online. So, and if you check the resource consumption, you see that we are really already have maxed out everything. So CPU. See, we are running at 100. That explains why it's a little bit slow to respond. The host is not maxing out, but the VMs that are maxing out. That's why you see this slow response time.
Yes, that's high.
Yeah.
So what is responsible for that iCPU consumption at this time?
If
Is
I
it
check
visible?
the task, let's see. The processes that are running right now.
Process. Can you go down? Let's see if we'll see something bigger. But it should be
Task
SQL.
Manager, runtime, SQL Server, failover cluster. Let me sort this one out. Yeah. Okay. So all this SQL is part of it. All these little things. I mean, the VM doesn't have a lot of resource, right? So when all these things are running also, they are. Okay.
So close the task manager as well because it's resource intensive.
Let me actually kill everything now. Okay, I see SSMS is running, trying to open up. Come on. Jesus, 9,500. This is. I don't understand why it always runs well when probably, no, not really. Zoom is not consuming it. Zoom is not in here, but I just need SSMS to open. All right, let me close the class manager. Wow. Close. Oh, there you go. Finally coming up. Okay, all right. So SSMS opens up. Just like regularly, you will connect to SSMS here. You can see that it automatically connects to SSMS using what? The virtual cluster name that we created called MPITR and the instance name. So it doesn't really matter right now which server is online because remember, otherwise, if you, this would have been node1 / MPIT class. But what if node1 goes offline? How do you going to connect? So in this case here, it really doesn't matter. This virtual name will always take us to the active node at the moment. So if you click connect, it connects. Can really see that it's slow. Just the connection takes really some time to connect, but I've worked with it sometime and it wasn't really not this slow. All right, so close this. All right, so it finally failed over and it's running on node 1 now. So I don't really care where I'm connecting to. I can launch SSMS on node 2 and connect. It's always going to connect via what? The MPIT as the virtual network name and the instance name base. So it reroutes connection always to the primary, right? Connections are always going to be rerouted to the primary. Try it one more time for that connected. Click. Jesus Christ, this is, close this. Close window, let me make sure I don't close the right one. I click on this. I close it. I close this. Wow, slow.
Doctor, while waiting for that, can we also fail over the quorum?
Yes. So let's go back to node 2. And then you see, so one thing, guys, that you want to see that, then you see that the quorum doesn't fail over. When you do the fail over, the quorum will sit on the same node. So if you really need to fail over this quorum, there is a PowerShell command that you can run to move this quorum from the location where, let's say during patching, and you want to really make sure that the host cluster is not hosted on the server that you're going to patch and reboot. You have to also fail over this quorum. And Foster, do you have the PowerShell command? There's a PowerShell command.
There's a GUI. We can do it GUI. Go
okay. Cluster itself. Okay.
Yeah, the storage. Yeah, go to the cluster and go to the storage. Open the storage so we can see it failing over.
It never allows me
the cluster. Okay, it's on 2. Okay, so now let's go on the cluster. Right click on the cluster. So I just want us to be here so we can see it failing over.
Okay.
Yeah. So the failover is done at the cluster level.
Okay.
Yeah. Right click and then go to move action. More actions.
More action.
And then move cluster core resources, and then select. Yeah.
Okay. Okay. So
no, hold on, go back.
There you go. It did.
Yes, there it is. It moves.
Right. It moves to.
So if you go back to the disk, you get to see that it has moved now to node.
There you go. It moved to node 1.
Yeah.
Right.
So the quorum is, you do the failover of the quorum at the cluster level.
Okay. Right. It's very important that you
that's
report.
right, Foster. When you fail over, it doesn't fail over the quorum.
Right.
Yes.
So if you want to fail over the quorum, you have to manually go through this process.
Fail it. Yeah.
Yes.
So you can do it manually, or there's a PowerShell script that you can run to fail.
And the benefit or the reason why you will want to fail over the quorum as well is what?
It's during patching.
Maintenance window.
Yeah, I just wanted to ask that for the record.
All right.
Yeah.
Okay,
so
guys.
If you want to patch,
yes.
Okay, go ahead. So if you want to patch a server that has the quorum sitting on it, you want to fail over the quorum to the secondary to the primary, sorry, before you patch.
Yeah. So I've not really been very lucky today with this SSMS. I wanted to, but you already saw that it will connect directly on the, it will connect directly using the cluster. It's too slow, and I really don't know why it's so.
Dennis, I think at this level, we already know what to happen next. Some of the most important part that people really needed to learn from, we've gone past all of that. So at this point, we know that everything looks good. So just to really do that confirmation, we've done the failover, we've failed over the quorum. So we've seen some of the most important things. I think the aim of this webinar for today has really been achieved. I want to thank you very much.
All right. Okay.
Yeah.
Thank you so much, guys. And I hope we did learn something. It was a little bit longer than we thought. Resources
Great job. Great job.
Resources did. But that was it.
This is my first time sitting down in your class 100%, and you've done a great job. You are flying.
Thank you, Betty.
Yep.
Thank you so much, Dennis. This was amazing, and I mean, it's something that a lot of people are going to take and make valuable use of a traditional failover cluster. Amazing presentation.
Thank you.